Hello friends, welcome to our channel. Today's topic of our video is construction of a DOL starter, where we use direct online starter. An advantage, disadvantage. Let's start this video. Construction of a DOL starter. A DOL, direct online starter, is a type of electrical starter used to start and control the speed of three-phase induction motors. Here are the steps to write a construction of a DOL starter. The main components of a DOL starter include a contactor, overload relay, and start/stop push buttons. These components are housed in a control panel. The contactor is a relay that controls the flow of electricity to the motor. It is typically made up of a coil, contacts, and an armature. When the coil is energized, the armature pulses the contacts together, allowing electricity to flow through to the motor. The overload relay is designed to protect the motor from damage due to excessive current. It is connected in series with the motor and measures the current flowing through the motor. If the current exceeds a certain limit, the overload relay will trip and cut off the power to the motor. The start/stop push buttons are used to control the on/off function of the DOL starter. When the start button is pressed, the contactor is energized, allowing electricity to flow to the motor. When the stop button is pressed, the contactor is de-energized, cutting off the power to the motor. To construct a DOL starter, first mount the contactor, overload relay, and push buttons in a control panel. Make sure that all components are wired correctly and that the appropriate fuses or circuit breakers are installed to protect the circuit. Next, connect the three-phase power supply to the input terminals of the DOL starter. Connect the output terminals of the DOL starter to the input terminals of the motor. Finally, test the DOL starter to make sure that it is working correctly. Press the start button and verify that the motor starts and runs smoothly. Check the overload relay to make sure that it is properly set and that it trips when the current exceeds the limit. Where we use direct online starter, this causes the motor to draw a large amount of current, making it only suitable for motor powers up to 4 kW, with a maximum motor size of 10 kW connected this way. Motors above 4 kW should be wired using a star-delta configuration method. The maximum size of a motor allowed on a direct online starter may also be limited by the supply utility. In summary, the maximum motor size that can be connected using DOL starter is 10 kW. Advantages of a DOL starter: simple and inexpensive. A DOL starter is a simple and inexpensive way to start and control the speed of a three-phase induction motor. It does not require any complex or expensive control circuits, making it an ideal choice for smaller motors. High starting torque. A DOL starter provides high starting torque to the motor, which is essential for starting heavy loads or loads with high inertia. Robust. A DOL starter is a robust and reliable type of motor starter that can withstand harsh environments and heavy usage. Easy to maintain. A DOL starter requires minimal maintenance, making it a cost-effective option for many applications. Disadvantages of a DOL starter: high starting current. A DOL starter can draw a high starting current, which can cause voltage drops and other issues in the electrical system. This can also result in damage to the motor windings and other components. Mechanical stress. A DOL starter applies full voltage directly to the motor, which can cause mechanical stress on the motor shaft and other components. This can lead to premature wear and tear, reducing the overall lifespan of the motor. Limited control. A DOL starter provides limited control over the motor speed and other parameters. It is not suitable for applications that require precise speed control or variable torque. Not energy efficient. A DOL starter is not energy efficient, as it draws a high starting current that can cause energy waste and increase electricity bills.